The .NET Core podcast is supported by our listeners who have become patrons. To see a full list of the patrons, or to join them, head over to .NETCore.show/patrons. Hello everyone and welcome to the .NET Core podcast, the only podcast which is devoted to .NET Core, ASP.NET Core, EF Core, SignalR, and not forgetting the .NET Core community itself. I am your host, Jamie Gaprogman Taylor, and this is episode 26, Plastic SCM with Pablo Santos. In this episode, I interviewed Pablo about the cross-platform source control system Plastic SCM, how it has been written entirely in .NET, created before Git, and even has its own distributions of Mono. So let's sit back, open up a terminal, type in .NET New Podcast, and let the show begin. Pablo, thank you ever so much for being on the show. I realize you're a very busy person, and we can go into that in a little bit if you like later on. But I just want to say thank you ever so much for taking the time to have a chat with me today, because it's fantastic to be connected with you, and I'm really eager to learn all about the stuff we're going to talk about, and for the listeners to learn about it too.
Well, actually, thank you, because it's great for me to have the opportunity to be in your show.
Thank you ever so much. So I guess first off, for the people who may not know about you or the company that you work for or the products that you make, I was wondering, can you give us a bit of an introduction to, again, you and the company and the products and things?
Absolutely. So, well, my name is Pablo Santos, and I'm the founder and CTO at Cody Software. We are a Spanish company. We are based in Spain, not Madrid or Barcelona, just a smaller city north of Madrid. And we are crazy enough to develop a version control system. So, there are not many version control systems out there. We are in the Git era, but we developed one called Plastic SCM. And, well, we are lucky enough to be, this is like our 14th year in business, right? So we have been around since 2005. And, well, we have customers all around the world, from really small teams with just 2 people to huge corporations who purchase more than 3,000 licenses of our product. So, well, that's what we do. Our entire world goes around version control, right? And branching and merging and all those sort of things.
I'll just dial back a little bit for some of the listeners who maybe are so used to living in Git. I'll just point out, obviously, that there are lots of other source control systems. But I remember when we were chatting before and chatting with some of your colleagues, how the first version of Plastic SCM was released ahead of Git, so it's a long time that it's been out. A lot of pedigree, I guess, has gone into this. Could you give us a bit of a 10,000-foot overview of Plastic SCM and source control I know there are some people who don't use source control,
Okay, absolutely. So, well, Plastic is a version control system built around a few key concepts. We wanted it to be very easy to use, and we always got .NET developers in mind, because we are actually .NET developers. So it's very easy to use, but at the same time, super powerful. I mean, it's super strong with branching and merging, which are normally two difficult things in the heads of many developers. So we are especially strong with that. We also develop very strong GUIs. I mean, it goes really related with the thing of usability and all that, but really visualizing the repositories, having really good diagrams around all that. That's our core, right? That's the things we do well. Then Plastic can work distributed like Git does, or it can also work at the same time centralized, like Subversion or all these other systems, which is very good for some teams. And we're especially good for game developers, because Plastic works quite well with super big files and big projects. I mean, we have customers with repositories that are larger than 4, 5, 6 terabytes, and that's not a problem for Plastic. So from a very high level perspective, that's what Plastic is about.
Wow, okay. 4 and 5 terabytes. That's a lot of files.
That's certainly big, right? But there's this thing, especially in the gaming industry, there are some teams who wonder whether they should put the code and also the other assets they have, like, video, audio, 3D stuff, whether they should put it on the same system or not. They like to put it on the same system because then life is easier for them. And that's why we try to handle, right? Simply like, okay, put everything you want in Plastic. We will just handle that. And that's our job.
Wow, that's amazing. Hopefully we can get into some of that. I'm just going to take some key points that you'd raised there a few times. So obviously you've said distributed source control and centralized source control, and you talked about SVN and some of the other competitors, I guess is the correct word. But you also said that it's .NET. So is Plastic CM written in .NET? I know you said that you are very much .NET developers, but is it .NET or is it something else and you sort of hook into it with .NET?
Plastic SCM is like 99% written in .NET. I mean, or server code or client code, like everything is written in .NET. Back in the day, it started back in 2005. It was sort of it was a challenge because it was like, should we go .NET for this? Because mostly all version control systems are basically written in C or C++, right? Because you need to be cross-platform. I mean, if you want to be let's say a professional version control system or a serious version control system, you need to be cross-platform. So we wanted to be cross-platform. And then you need to be fast. The good news, and that's something I love about .NET, is that, okay, you can do it. And in fact, we have many benchmarks where we are even faster than, system written in C, right? We can say, yes, we are a .NET.
Wow, okay. I do like that you were saying there are parts of your system that are faster than code written in C, and as good as C is, and it's great, very, very powerful and very, I guess, inherently cross-platform. I mean, we'll talk about .NET Core in a moment, but C is inherently cross-platform and it's very fast, but it's also very, very dangerous. So I remember when I was at university, from 2004 onwards, we studied computer science, but we used C# and .NET in the first year to sort of, for some of the newer folks to get their heads around some of the more esoteric development things. And I remember when the lecturer was challenged about this, somebody had said, hey, why aren't we learning C like all the people in the other universities? And he said, C is very good, but C is like a chainsaw. If you do it wrong, you're going to lose a limb. You know what I mean? It's very, very fast and very, very dangerous. So I could totally understand that. And, .NET isn't inherently slow. A lot of people, even back in .NET version 1, a lot of people said, oh, well, it's managed, so it must be slow. But it really isn't, is it?
Yeah, exactly. I mean, well, there are a few things here, right? I mean, if you do like a tight loop where you're going to calculate something, okay, chances are C is going to be faster. But real life code is never like that, right? You have I/O, you have network, you have different components, and then you have the algorithm you develop or the way in which you chain things together, right? So for instance, we consistently beat Git in tests doing commit of a huge amount of files, like 500,000 files or something like that. We're about 3 times faster. And considering that, or in order to do a commit in Plastic, it has to go through the network. Even if it's local, we go through the network layer and we do compression and we do a number of things. Many of them they do too, right? We do that in C# and we beat it consistently. We use multi-threading for that, but of course, adding multi-threading to a C# application is like nothing. Doing the same on C is much more difficult. I mean, there are many things that are super simple to do in C#. So that's why back in the day, we decided to go in that direction. Of course, there are also some, rough edges you have to take into account when you write high performance code. It's like, there are many mistakes like a C# developer you normally will do that as a C developer you wouldn't do, like, reserving too much memory or just, okay, it's so easy to just do new for a byte array or something like that once and again, and then you don't care really about what's going on underneath, and then you pay the price because the garbage collector is going to hit you back or something like that. But at the end of the day, if you are careful enough with the code, before programming in C#, I did a lot of C++ and also Java and also even Delphi. I don't know if you remember that. It was Object Pascal. And first, my first contact with C# was like, wow, it works. I mean, it just works. I mean, I was doing something through the network or something, and it worked. And I remember during all my days with C++, it was like, it never worked the first time. It never worked the first time. You forget this or you forget that or something is missing. In C#, you just put it and it works. And that was a feeling that made me think, wow, I love this language. And that's one of the key reasons why we decided to go for it back in 2005.
You see, that was going to be one of my next questions was, Because Git is written in C, and I guess SVN and other things like that will probably be written in C++, or like you say, Delphi. I was interested to find out what the big challenges were with being .NET only in the early days. You know, I mean, we live in a world now with Core and Mono and all the other .NETs. You know, we've effectively got cross-platform .NET. You need to do a little bit of work if you're already in framework to move across. But back in the day, it was Windows only. So, you know, what did you have a lot of, I guess, pushback from your customers saying, oh, we can't use that because we don't have a Windows machine? Or how did you get around that?
The reason why we really went for C# and .NET is because Mono was there. Even back in 2005, it was already there. And since it was there, we made the decision to actually go for .NET because, I mean, it wasn't an option for us to go Windows only. Because then, I mean, as a version control system, you are sort of the operating system of development, right? It's like the foundation where everything else builds up on, right? So we wanted to be cross-platform from day one. And yeah, we were happy to find that Mono was there. It was, of course, not as mature as it is today. And of course, there were things that didn't work as we expected, and there was a lot of trouble here and there. But mostly, it proved to be a good decision, right? So yeah, to answer your question, we never were a Windows-only system. We ran on Linux and Mac from day one, thanks to Mono.
So does that mean then that your development process was Mono across the board? So you would install the Mono development kits on everyone's machines, regardless of what they were running, and you would target that? Or did you have some developers who were using Windows machines and were building against .NET framework, and, you know, other people were building against Mono and then finding that the code didn't work so well?
Well, it was most like the second choice, right? We had people working on Windows, and we also have people working on Linux, and we had versions. I mean, it's the same binaries at the same day, but we build them in Linux and Windows, and we tested. Specifically, we tested the binaries on Windows, Linux, and Mac from day one, right? So we have a test system built around NUnit, which we call PNUnit. It's a piece of code we contributed back in the day, and it stands for Parallel NUnit. And we wrote that to actually be able to run tests on different systems at the same time, right? Like, okay, we run our tests on the three platforms from basically, I won't say from day one, but probably after just 4 months in development, after we started the company and so on, we were already having cross-platform tests. So it's more like what you said. I mean, we had some environments on Windows, most of them on Windows, to be honest, but then we also always had machines on Linux and Mac using Mono.
So then when you were producing your builds, let's say the Windows build, was that using .NET Framework, and then Linux and Mac OS were using the Mono runtime? Or was it, let's use Mono across all the devices so that we get the best sort of binary compatibility?
No, it was actually .NET for Windows and then Mono in the other two. From a binary perspective, it worked quite well from, I would say, ages, right? The only challenges we faced is that actually having the Mono runtime on all the platforms, it was not that easy because then you have to, introduce some dependencies. At the end of the day, what we ended doing is that we built our own Mono. I mean, it's been already like 8 years or so where we build our own Mono based on an official release. We have an entire setup to actually package our own system on different Linux flavors, and that's what we have. On Mac, it's much easier because there's like a single distribution. On Windows, it's the same with .NET, but for Linux, we have like 5, 6, 7 distributions we support, and then we build our own packages. And the reason why we don't use the Mono defaults is because in some of the platforms, they were not, officially maintained and stuff like that. So we became, I wouldn't say we are like maintainers or anything of Mono, but we actually package our own thing using, standard Linux packaging systems.
That's one thing I hadn't even thought about. So I can appreciate the overhead involved in that because at home I run a MacBook and a Linux desktop and, a Windows laptop. So I have experience with using the majority of those different forms of operating systems. And I can't even imagine how, like, you've said that these products, you support Linux, but Linux isn't an operating system, it's the kernel, isn't it? It's the distributions of Linux. So I can't even imagine like the overhead required to support, let's say, Debian and, I don't know, Fedora, and I'm just pulling these out of the air. I don't know whether these are the actual distributions that you support.
These are actually.
Oh, wow, okay. Good guess.
Yeah, the thing is that, well, there's this very nice piece of software made by SUSE long ago, which is called OVS. And then it lets you basically have like a build machine where you can create packages for many different distros. So that's what we do, right? So the funny thing here is that while Plastic itself, the binaries are cross-platform because they are just, .NET binaries that you should be able to run anywhere. We actually, on Linux, as we said before, we are actually building the monos for Linux, right? So we build the mono for CentOS, for the Debian, for Fedora, for SUSE, and for Red Hat, right? And then that's what we do, right? So we basically support a bunch of different versions. So when a customer wants to try Plastic, they just have to run their favorite package manager command, and then they get it, and then we have the repo set up and everything, and they just install it. It's a big of overhead, as you said. I mean, by far, Linux is the most difficult one to maintain your software because in the other two, it's just a single distro. But, well, I mean, we need to do it. So that's what we do. I mean, even to the present day, I mean, even like every single release we make, and we make like 2 or 3 official releases every week, each of them is creating new packages. So if you go today to Plastic SCM website, you will see how to install one of these packages on Linux.
So, yeah, I'm actually blown away by how much effort I'm perceiving there is involved in that, and I probably I'm probably not even thinking of. I'm only scratching the surface because I've not done proper cross-platform using different distributions of Linux. That's amazing. So just for the listeners who are either mainly Mac OS or Windows based, like I'd said there, people say Linux, and I hope you can hear the bunny quotes I'm using. There is no Linux. There's a Linux kernel, which is the kernel of the operating system, and then there are distributions of software built on top of that, or distributions of operating systems built on top of that, and there are families of them, and different distributions have different ways to install applications and different ways to manage the whole system, and then on top of that, you've got the desktop environments and all of that kind of stuff. So I guess, how do you manage the user interface then? So for Windows developers, we, at that time, we kind of had Windows Forms. And I guess Mono, we had something similar using GTK. But what if you weren't using, I believe that needs GNOME as your desktop environment. What if you weren't using GNOME? Are there shims you can include, or does it just work?
That's actually where the fun starts, right? So we started developing all our GUIs using WinForms. And then for a while, we were lucky enough to run monoforms, as they call it. So we had exactly the same look and feel on Windows, Mac, and Linux. And they were basically like Windows Forms applications running on the 3 systems. That's how we actually started, and it actually lasted for a few years. What was the problem? Well, the thing is that Mac users, as you know, are quite picky about the GUIs they use, right? So a WinForms-like application running on a Mac, of course, it doesn't mean that the window itself looked like a Windows 1 or something, but it's more like the controls inside and so on. So it looked pretty alien on the Mac, right? On Linux, probably it also looked alien, but since there's not such a strong standard, or the users on Linux are not so demanding, I would say, about the GUIs, so it wasn't that such a big issue. So it worked for a few years. We had a lot of issues with that because we basically wasn't able to rely on some standard controls on Mac and Linux because it didn't work perfectly there and so on. So we ended up rewriting many controls to have like sort of a similar look and feel in all platforms. I can share some screenshots of that, and I can send you the link to share with the listeners later on. But then, like around 2012, a few years into development, we decided to rewrite the GUI, right? So we kept the Windows Forms one for Windows, and then we created a GTK Sharp one for Linux, and a Xamarin Mac, a SAMMac as they call it, for Mac OS. And that's how we run till this day, right? We have like a shared code base, but then there are specific GUI parts, GUI pieces for WinForms, GTK Sharp, and SAM.Mac.
So you've architected a way, I guess, so that you've got, like you say, you've got that common code base that's sitting underneath the view, and then you have a almost like an MVC or an MVVM pattern, I guess, so that then you have a separate view system per operating system that matches, I guess, what people would assume a Mac OS application would look like, or a GTK application, or a WinForms application.
Exactly. Well, the actual functionality is going to be the same, but there are differences in how the actual look and feel is on each platform. Like, for instance, you go to Mac and then your OK and cancel buttons are inverted, considered to what you will have on a Windows box, right? So this is just a small example, right? But there are many other things that are slightly different on the different systems, and that's what we do, right? So this way, we are free to customize each of the GUIs for every operating system, while the core is the same. If when we only had like a single GUI for all of them, together with this issue of looking a little bit alien, it was not that easy to like customize something to look more, well, to look better for Mac users and something like that, right? So yeah, what we do is to have like a shared part of the code, and then of course there are some, I wouldn't say duplicated, but there are things that need to be done again and again. I mean, like you have a dialogue or something, you have to do it 3 times.
If we take a step away from the view, then I've never built a version control system, but when I'm committing into Git or SVN or something, I always get these hashes back, right? It seems like so I can make a commit. I've made loads of changes. I get a hash number back based on, something to do with, there's some magic there that happens, right? Learning how to do that, I feel now would be relatively easy. There's a lot of documentation out there on how to do it, but learning how to do that back in the early 2000s, learning how to build a distributed and centralized version control system in the early 2000s when there were no other big players in the how did you guys do that?
Well, I think it's a very beautiful story because, the feeling I have 15 years down the road is that, well, we were young and naive enough not to know how we were going to do it. So we just did it, right? It's like if you probably know too much about all the issues you will encounter and how difficult it would be, then you won't probably do it, right? But we were, yeah, as you said, there wasn't like that much documentation about what need to be done. So we just figured it out, some ways, and we did it wrong for some times, and we had to retry this or redo that, and we did it so many times because at the end of the day, our code base is like, I mean, it's been with us for years, right? So we need to keep it clean and so on. So basically, what we did was just to try to. We had some ideas. We spent some time on design. Okay, how can we do this or that? How can we store the revisions? It could be better to hash it this way or this other way. Should we store it on one way or another? And we just went through it, right? So it was like, yeah, I'm sure we did a lot of things wrong, especially at the beginning, but now it's like, well, we went through it. So yeah, it's been a very nice trip so far.
So I would imagine that there's, like you say, there's a lot of algorithm design and API design. I would imagine there's a lot of number crunching and a lot of maybe cryptographical stuff that you need to do. Maybe not so much cryptographical, but definitely number crunching. Did you find at all that maybe the .NET code behaved differently to the Mono code? Because I know that a lot of the early Mono code was sort of a black box re-implementation of .NET, because obviously there's a lot of documentation around in the way of you give string.format a bunch of inputs and it will give you an output, but there might be millions of different ways to write that method. So did you find that in the early days at least, .NET Framework and Mono behaved differently for different functions in different situations?
Actually, the developers of Mono weren't able to actually look into the .NET code. Even disassembling the stuff or something, they were not allowed to do that because then they will break the license terms and all that. So they, as you said, they actually had to rewrite it their own. But as incredible as it might sound, they did a super good job, right? So we didn't find so many places in the code where it behaved differently. We could probably find some performance issues, like something that is faster on Windows is then slower on Linux and something like that. We hit that many times. But in terms of functionality, I would say we just found a few points where they behave really different. And there's one I know by heart, which is, like file system watcher. Okay, you cannot really use a file system watcher on Linux or Mac because it doesn't work well at all, because they are trying to mimic the Windows behavior on a system that simply works differently, right? So, but there are other few places where that also happened, but there are not as many as you would expect. For instance, there's a piece of code that is awesome, which is the .NET remoting. Now it's completely deprecated, but I fall in love with it when I first found it because I was a DCOM developer before that. I used to do, some distributed COM interfaces and so on in C++. So when I first met .NET remoting for the younger audiences like Windows Communication Foundation or even like the later, I don't know, Google Protocol buffers or stuff like that, right? Well, it was like a protocol made in the early days, and it worked surprisingly good. I mean, it was doing a lot of stuff, and it simply worked. And that's actually how I felt in love, right? I actually wrote a small test client and server using remoting, server running on Linux, client working on Windows, and it just worked. So I have to say that what the Mono developers did was simply amazing, right? So it wouldn't be fair if I just complain about the little things we found on the way, because it's like, yeah, there are little things here and there, but overall, it's amazing what they achieved.
That leads me on to a question about Mono. When you and I and your colleague Geordie were discussing this episode and how we were going to do it off air, I think it was Geordie brought up the fact that because you guys used Mono a lot, Miguel de Icaza actually, I want to say, got involved with sort of looking into some stuff and did a case study and things. Is that correct?
Yeah, they just recently published a case study telling a little bit of the story how we used Mono over the years. Yeah, that's correct.
Wow, fantastic. Because he's like the grand architect of Mono and Xamarin and essentially where .NET is going, I guess.
Yeah, well, I mean, he's an amazing guy. I was lucky enough to meet him personally a few times. In fact, in the first show where we ever introduced Plastic, that was back in 2006 in TechEd Developers in Barcelona. Well, we went there. It was the first public event as a company, as a team, as everything. And Miguel de Icaza was actually there. That was the first time we meet him. And it was amazing. And after that, we meet in person a few times. I tried to email him to tell how we're doing and so on from time to time. And well, I mean, it's one of these amazing developers, world-class developers, one in a million. And so it's always like a pleasure to just get in touch with him, right? So yeah, I'm a big fan of him. So
I was just going to ask, since obviously Plastic started as a .NET framework and Mono application, obviously the subject of the podcast is .NET Core. And I realize it's a monumental engineering task, but are you planning to, or is there a plan to leverage maybe a little bit of .NET Core, or are you quite happy with Mono at the moment?
Yeah, I mean, we are super interested in .NET Core. In fact, there are parts of the system that already use it, right? And even parts that are not a piece of the main software. For instance, our website, plasticscm.com, is completely written in .NET Core. Currently, we just switched it. I mean, we just migrated last year, right? So it's there. Of course, that's not part of the main piece of the product, but it's an important piece of software for us. And then after that, yeah, we've made several tests, especially on the server side. I mean, I don't think we'll be moving the client side of things soon, although I might be mistaken, but I think the client will continue in .NET for a while and probably Mono for a while too. But the server, we have a plan to actually migrate it as soon as possible to .NET Core. We already ran tests. I mean, for the last, I would say, year and a half or even a little bit more, we started doing migration and we got a build completely running on .NET Core like 1 year ago or even a little bit more. We ran some performance tests. We even were lucky enough to be in touch with the .NET Core team, and there are some developers there who even use Plastic to make some benchmarks on the early days. We provide them with environment to actually, do load testing and stuff like that, and they were able to compare .NET with .NET Core using Plastic on Linux and then compare to Mono and so on. So just answering your question, yes, there's a plan to actually do it, and my personal goal is to end this year with official server, Plastic SCM server running on .NET Core.
That's really cool. I just want to point out to listeners, obviously, this is Pablo's goal, his personal goal. This is not a business goal. This is not him announcing in public, hey, this is what we're going to do with the product. That's just a goal that he has set himself. So it's not an official thing that he's saying there will be a version by the end of the year, just that it's one of his goals. I hope I'm not treading on your toes there, Pablo. It's just I want to avoid setting expectations for you there. I don't want you to have to hold yourself up to that goal of, yes, there will be a version, unless there is going to be a version.
Okay, yeah, I understand. For some of our customers, they don't really care what we run on. They don't care whether it's in C# or C or Java or whatever, right? But yeah, there's something interesting is that some of our biggest servers run on Linux. it's not that they run better than the Windows counterpart or anything. We are super happy with the Windows servers, but many customers prefer to have like super big servers on Linux because that better fits their culture or whatever. And surprisingly, some of them asked about, are you going to have a .NET Core? Before that, they never really cared whether it was Mono or anything. But I think .NET Core is doing a good job into the Linux and Mac users or community, or I don't know, overall industry, because many sysadmins running Linux servers now think .NET Core is a good thing to have. Well, probably they were a little bit more concerned about Mono, right? But now they have this view. So yeah, we got a few requests. Yeah, as you said, it's not like 100% thing that we're going to have it, but most likely we'll try to have it by the end of it.
A really super quick turnaround as well. You said that you had some tests last year and you were talking with Microsoft presumably shortly before that. Going from I have a stable, very important enterprise level, like you said, source control systems are the operating system of development. You have this very stable, has to work every single time, cannot fail system. And there's a new runtime that's been out for, at the time of recording at least, just over 2 years, and you're already, ready to make the jump to port over to it.
Yeah, the thing is, our server is built on like a minimum version of .NET, I would say. I mean, it's built on .NET 4.5 or something like that already, or 4.6.1 or something like that. But what I mean is that the code itself, since we always wanted to keep 100% compatible, even with old versions of Mono, just in case we had to run on a different platform or something, we had the challenge to actually run it in Solaris for a while, right? So we try to keep the code as simple as possible and not really making it, depend on the super very latest language feature. That actually made the move quite easy, because even some things that were not supported or things that, constructions that are not there, we were simply not using them. And the dependencies of our server are minimal, which means one of the main concerns, especially in the early days when you try to go for .NET Core, is that, well, maybe my code can build there, but what about my dependencies? I can have like a ton of dependencies that are not ready for .NET Core. Since our server is so small in terms of dependencies, it was not that hard to build it. So it took a while. I mean, it took like probably a month worth of work actually, tweaking the build system. But what we built was actually like a core version. It doesn't have like the entire functionality, but what it does is quite complete. I mean, for instance, our Plastic SCM server, the regular one, can use SQL Server or MySQL or Postgres or Firebird or a bunch of database system as backend. So it stores the data and metadata on standard databases. Of course, in this .NET Core run, we didn't support all of them. We just support the bare minimum, right? Or for instance, our system is integrated with LDAP. You can get the information about users and groups for LDAP. Well, this .NET Core build didn't have LDAP support. It was just using a different, simpler system. So these are the shortcuts we made. But what we wanted to test is actually the entire scalability of the system, how it performed and all that. And these basic important pieces, I mean, what really makes Plastic, what's really running on that version. And yeah, it was not that hard because of this, how the code is written. I mean, it's a very small set of dependencies we rely on.
So because the dependencies are so small, you can move over. That's brilliant. I do remember when .NET Core first came out, like you were saying, there were a lot of NuGet packages and a lot of third-party libraries that were not ready because they were .NET Framework 4.5 or 4.6 or something, and there was no way to actually load those NuGet packages in, so you had to rely on everything that Microsoft had done, and then they came out with the standard, and then that changed everything. But it sounds like you don't even need .NET Standard to make Plastic work.
Well, exactly. I mean, we are happy it exists, and we, of course, now will embrace it. But yeah, we were able to build it even in the very early days.
Okay, so a couple of quick questions then. If you were to, let's say you were asked to start all over again with the technology as it stands now, would you use Mono still, or would you use .NET Core, or would you use Framework, or would you use a completely different technology? What would you, if you were to rebuild Plastic from the ground up?
Okay, if I had to do that all over again today in 2019, I would go for .NET Core. I mean, absolutely. I mean, it's the way to go. I think there's no doubt. I mean, as I see it, Microsoft is really going for it. It's going to be like cross-platform .NET officially supported by Microsoft with a lot of investment on making it better. And also, now it's really optimized for server loads, right? I mean, in the early days, .NET was able, and we actually proved that, to do intense server-side calculation and load processing and all that, right? But it was more like a desktop or client-side technology, if you allow me that comparison. But today, they are super concerned about making .NET Core really a server-side technology too. It doesn't mean it's just server-side, but it's two, right? And what I mean by that, I mean, look at all these advances in the way they deal the memory, all these new ways to handle pieces of or chunks of memory and put them all together, all these optimizations in how they handle the stack, all this stuff. This really makes .NET Core a good choice for the server, right? So yeah, answering your question, I will definitely go for .NET Core today. There are still a few small things here and there, like, okay, how would you build a GUI in .NET Core and Linux? Well, you have GTK Sharp, you are well covered there. What would you do on Mac? There's no Xamarin Mac yet there. But maybe, who knows, maybe we'll go for Electron or something like that, right? So that's also a choice. We are, as you said, thinking of what would you do today. Well, Electron apps are well understood and appreciated too nowadays. So yeah, that would probably be a good choice.
So because you'd said earlier on about separating the sort of back-end code from the front end, does this mean then if you wanted to, you could create a Xamarin front end for an Android device or maybe a tablet rather than a phone, I guess?
I'm thinking more on terms of desktop, right? So when I mentioned Xamarin.Mac, I'm thinking really on Mac OS, running on Mac OS more than iPhone or anything else. So yeah, but of course there are ways to actually, since we develop a version control, having an app is not that critical for us. We actually made one, but it was sort of experimental for Android a few years ago. But it was very experimental, like, playing a little bit with the technology and so on. So yeah, I mean, the magic in .NET Core and .NET in general is that it's really full stack, right? You can actually do the entire thing. Like, you can do super specialized server code. You can do code optimizations, and then you can also build a website, and you can build a desktop app, and then you can build a mobile app. I mean, nothing the audience doesn't know, right? But that's really the beauty of this ecosystem, that is really full stack.
Yeah, I mean, you can even run it in the browser now, because of technology like Blazor.
Absolutely. Yeah, and that's one of the things I'm more excited about, thinking about the future, that I'm really looking into that, and I'm really eager to see where it goes and to make some tests ourselves, because I'm really excited about Blazor.
So, and I realize a leading, very silly question. Plastic SCM in the browser?
Well, it's not silly at all. It's something that pops up, I think, every second week, right? Like the entire team is thinking whether we should go in that direction. We have an investment right now into the desktop code all around, right? Like, we have all these versions running and so on. So it wouldn't be like super fast to actually move that to a browser. And I would think on Electron or something like that, because, in a version control, the thing is that you need to have something running on your computer. It cannot be completely web-based, because you need to access the files on disk, you need to get them and upload it to the server and stuff like that. But maybe a Blazor thing could be a possibility. That's something, it's not the first time it pops up. We were discussing this many, many times already over the last few months.
Fantastic. Okay. So just to sort of round it up then, because I realize obviously this is bleeding into your late evening, I guess. For the listeners, we're in completely different time zones. Not too dissimilar, but obviously it's later for Pablo than it is for me. So I can appreciate that he's had a long day so far. So just a couple of questions, if that's okay, Pablo, along the lines of, so if I wanted to learn more about Plastic SCM, obviously I can go to the website, or is there a Twitter, or, how can I get in contact with, I don't want to say the team, because I don't want to say that people should be contacting the dev team directly, but is that an open channel? Is there a way to get in contact?
Well, of course, I mean, the main place to learn more about Plastic is plasticscm.com. So you go there, you'll find all the information. And of course, you can always find us on Twitter at Plastic SCM. And yeah, I mean, in fact, you'll be able, if you want to engage with the actual developers. We are a small team after all. We are like 20 people overall in the company. We are quite a compact team. So one of the great things about a team like ours is that, it's not difficult to engage with someone, because we are not like super big corporation or anything. So yeah, that's one of the fun parts.
So yeah, definitely listeners should head over to the Plastic SCM website.
So yeah, I'm on Twitter. My handle is at psluaces. Probably you can share it later on the website. And yeah, I'm more than happy to talk about anything code related, right?
Fantastic. And just one last question, and this may be more of a marketing-y type question, but so Plastic SCM, is it for enterprises? Is it for, I know you mentioned earlier on about games developers using it, but does it have to be a big company? Can a startup use it? Can people use it to do their own sort of personal projects? What's your target market?
Well, it's quite wide, right? We have from very small teams using Plastic, like just 2 people doing, an indie game or something, and to really big corporations using it. And we have free versions for individuals. Like if you are an individual who just want to give it a try, learn about it, or use it for your personal project, it's free for you. It's also free for open source projects and non-profit organizations. And then we have a very affordable price scheme for small teams, and then a little bit more expensive for corporations because we get more features and so on.
So if someone's after checking out Plastic SCM, they could maybe create a small project of their own as a sort of personal project and try it out, and then maybe go to their boss and say, hey boss, we should move away from Git or Tortoise SVN or TFS or something and start using this.
Yeah, absolutely. I mean, fortunately that happens a lot of times for us, right? Like individuals and developers just giving it a try and then going to the company and saying, hey, look, I found this. The other super good thing I would say about Plastic is that I like to say that I think the product, of course, is good. I mean, I'm biased, absolutely, but that's where I put my entire work life into making it good, so I believe it is. But there's something even better, which is our support team. We have a super responsive support team, so any questions, doubts, things they can help you with, we answer like 85% of all questions in less than 1 hour, which is like huge, right? And so we are really focused on doing that, a very good experience.
Wow, 85% in less than an hour. That's impressive.
Yeah, we are lucky to have such a talented support team. So yeah, they are all former developers. They work on the core of the system. They really know what they talk about. It's not like they don't know the product or they just will drive you to the documentation. They really know it cover to cover.
I guess all that really remains to say is thank you ever so much for being on the show, Pablo. It's been incredibly interesting to talk to you about Plastic SCM and amazing to be connected with you today. It's an incredibly fantastic sounding product. And, just talking about, you say that you had a core of developers using Windows, using .NET, and a core of developers using Linux distributions, using Mono, packaging all of that up and creating your own distributions of Mono. All of that is amazing. I may have to reach out to you again and have you on the show to talk about how you did all of that too, if that's okay.
That would be awesome. I had a really good time today, so I'm super happy. Thank you for hosting me today here, and it was a really great experience, so thank you very much.
It really has been incredibly interesting, and if we can connect again for another episode, we can talk about the Solaris story. I'm incredibly interested to find out about that.
Absolutely, that would be super, so thank you very much.
Thank you ever so much, Pablo. That was my interview with Pablo Santos. Be sure to check out the show notes for a bunch of links to some of the stuff we covered and a full transcription of the interview. The show notes, as always, can be found at .netcore.show, that's dotnetcore.show. My thanks go to Sean and Dan M from the Linux channel on the Coding Block Slack group for helping me to identify the Open Build service from OpenSUSE, and to Productivity in Tech for providing the transcription of this interview. And don't forget to spread the word. Leave me a rating or review on your podcatcher of choice, and to come back next time for more .NET Core goodness. I'll see you again real soon. See you later, folks. The .NET Core podcast is supported by our listeners who have become patrons. To see a full list of the patrons, or to join them, head over to .netcore.show/patrons.